Yeah, so the first one says, we should use the definition of a derivative to differentiate the following, which a is x squared minus x plus 1. And we know that we're going to use the definition of a derivative. We're talking about first principle, right? It's x squared minus x plus 1. So we know that f of x is equal to x squared minus x plus 1. So first, obviously, I must write the definition of a first principle. Which we have this all over h. So let's confirm if this is really recording. Yes, it is. So let me turn off the system sound. So now we have this, right? And then now we know that we have f of x, which is this, and we need f of x plus 1, plus h. So we're going to say this. So let me just write it here. I'm going to say f of x plus h will be equals, wherever there's x, I'll substitute with this, right? Squared minus x plus h plus 1. You see, right? And then this will lead us to having the limit. We'll have the limit as h approaches 0 of, we know that f of x plus h is x plus h squared minus x plus h plus 1. And our f of x will be minus x squared minus x plus 1. Alright, this will be all over. What is this? Over h, right? Then this will be equal to the limit as h approaches 0 of x squared plus 2xh plus h squared minus x minus h plus 1 minus x squared plus x minus 1, which will be all over h. Right, then we'll have the limit as h approaches 0. Then we see that x squared will cancel x squared, then x will cancel x, and 1 will cancel 1. So I say that here it's preferred that we are left with anything that has h, as long as we're not dealing with one-sided limits, right? Then we should be left with anything that has h. So this will be, the limit is h approaches 0, then we factor out h, 2x plus h minus 1 all over h, and h can cancel out. We'll be left with the limit as h approaches 0 of 2x plus h minus 1, right? And this will be 2x plus 0 minus 1, which is 2x minus 1, right? And if we go back, we try to derive this will be 2x minus 1. So that is correct. We have confirmed that if we derive that. So this will be the solution to the first problem, right? And then, is there any question? The second one, we had 2x to the third plus 1. 2x to the third plus 1. X to the third plus 1. And we know that f prime of x is equals to the limit as h approaches 0 of f of x plus h minus f of x all over h. So I'm going to be expecting you guys to get total on the upcoming quizzes. So it doesn't matter what type of a quiz they bring, I'm going to expect you to be getting total. So this will help boost your semester mark, right? So now we know we have f of x and we need what? F of x plus h. F of x plus h. And this will be 2x plus h to the third plus 1. Then now we can substitute. No, this is 2x plus h to the third plus 1 minus 2x to the third plus 1 all over h. And this is the limit as h approaches 0 over 2x to the third. So here's a check something here, right? X starts from 3, h will start from 0. Then the second one, x will decrease by 1 and h goes to 1. So h will increase while x decreases. Then this will be, now I'll add these values here, right? So I want to show you this. So we'll have x squared h plus x h squared. You see x decreases by 1 while h increases, plus h to the third. Now if we go back to Pascal's rule, right, which is next semester, you have 1 1 1. You see you need these 3 ones in the form of a triangle. Then you start computing. You say 1 plus 1, this 1 plus this 1 gives us 2. I want to get where I'm gonna get 3, right? Then I'll have 1 here, 1 here. Then I say 1 plus 2 gives us 3. 1 plus 2 gives us 3. Then I'm where there's 3 now. Our exponent is 3. So I see now that here I need 1. You see here I need a constant 1, which is the first one. Here I need a constant 3. Here I need a constant 3. Then here I need a constant 1. You see, right? Then this will be simple. So now we say all over h. You see, right? And then this will be the limit as h approaches 0 of 2x, I forgot to subtract this other ones here, 2x to the third, minus 1 there, minus 1. And then this is 2x to the third plus 6x squared h plus 6x h squared plus 2h to the third minus 2x squared minus 1. Did I forget that plus 1 somewhere here? Yeah, I think I forgot it. I forgot it somewhere. I can see it. I forgot that plus 1. Yeah, because I see that this thing needs to cancel. It needs to cancel out. There's no way. Yeah, if you cancel your things out and you find that you're left with something that does not have h, try to check if you made a mistake somewhere. Should be left with h only. Yeah, 1 over h, right? And then this would cause 2x to the third, which this is to the third. Why am I writing squared? This would cause 2x to the third to cancel out and 1 to cancel out. So check, the only things that were left out with is the ones which have h. You see, have h, have h. Then we can now factor out h. We have the limit when h approaches 0 of, we're going to have h 6x squared plus 6xh plus 2h squared, right, over h. And this would be the limit as h approaches 0 of 6x squared plus 6xh plus 2h squared. Then I substitute my h. I have 6x squared plus 6x0 plus 20 squared, and this would be 6x squared. Then if you go back and try to derive this, you see you would get 6x squared, right? And then that is correct. So, any question? Any question? Any question? So, no question means that we can proceed. So, now we come to C, right? Let's check C, what is C saying. C, we have 1 over t squared. 1 over t squared. So I can have C, have f of t will be equals to 1 over t squared. And here I need to first write the rule of first principle with respect to t. If the limit as h approaches 0 of f of t plus h minus f of t all over h. And this would be, we know that we have f of t. What do we need? We need f of t plus h. And that would be 1 over t plus h squared. You see, right? Then here we'll have the limit as h approaches 0. Then f of t plus h is 1 over t plus h squared, right? And then we'll have minus 1 over t squared all over h. We agree? And then here I told you how to work around this one. I said that you need to take this by this and you multiply them, right? Here you take t squared by t plus h squared all over t squared by t plus h squared. And then from here, this will be the limit as h approaches 0. And then this one will cancel out this one if they multiply. You see, right? Then we'll be left with t squared on that side. Minus this would cancel this if they multiplied, and we'll be left with t plus h. Put brackets. You see, right? All over h. Then we have t squared, t plus h squared. You see, right? Then this would be the idea there. And then, now let's do this. Let's simplify the numerator and see what we get. Did I say t squared here? H approaches 0. T squared minus t squared plus 2th plus h squared. You see, right? Then this will be all over h times t squared times t plus h squared. I said that the denominator, you're not supposed to simplify it. You're supposed to leave the denominator as it is. And this will be the limit as h approaches 0 of t squared minus t squared minus 2th minus h squared all over, we have h times t squared. Oh, this thing doesn't want to write. Okay, it's fine. Let me erase it here. I'll write it on the other side. And then we would have the limit as h approaches 0 over t squared minus 2th minus h squared all over h. Then get something like this. Alright. Yeah, something like this. Then on the denominator we have times t squared times t plus h all squared, and this would be the limit as h approaches 0 of t squared would cancel t squared, this would cancel, then we're left with minus 2th minus h squared all over h times t squared times t plus h squared all squared. Then here would have the limit as h approaches 0, we factor out h, would have minus 2t minus h all over h times 2t times t plus h all squared. And then this would cause us to have the limit as h approaches 0 of minus 2 minus h minus 2t minus h t squared t plus h all squared. Then I would be forced to substitute 0. It's t squared t plus 0 squared, and this would be minus 2 over t to the 4. You see, right? Then that will be the case. So, any question? So if there's no question, we can proceed, right? If there's no question, I'm sure that maybe you got something like this, but if it was troubling you, now you know how to do it. Then I would say we do r of k is equal to 1 over k plus 1. R of k is equal to 1 over k plus 1. R of k is equal to 1 over k plus 1. And then R of k R of k is equal to 1 of k plus 1, right? So if we have r of k is equal to 1 over k plus 1, so it means that we can write the formula now, which is the limit as h approaches 0 of r of k plus h minus r of k, right, all over h. So you should be sure to write the formula as you are given. You see, here you are given r of k. So it means that here you just need to add plus h inside. You see, it should follow the context. So we know that now we need r of k plus h. And this will be 1 over k plus h plus 1. And then now we can come and direct substitute here. So r of k plus 1 is 1 over k plus h plus 1 minus, we know what is r of k, right? R of k is 1 over k plus 1. We divide by h. Alright. And now also I showed you how to compute this. You see, it happens a lot. It comes a lot. It's up to us on whether you want to know this or not. So I'm just gonna take this by this. So if you still get this wrong, I don't know what to say, because I've been showing it I don't know how many times, and I'm moving slow, trying to cover every question that we come across, so we don't have any regrets of not doing certain questions, right? Then this will be the limit as h approaches 0. If we multiply this and this will cancel, you agree, right? Then we'll be left with k plus 1 there. And then if we multiply this and this will cancel, we'll be left with minus k plus h plus 1. Alright, all over, we are going to have h k plus 1 k plus h plus 1. Alright, then this will be, we can simplify the numerator. We can have k plus 1 minus k minus h minus 1 all over h times k plus 1 times k plus h plus 1. So this we know that the k will cancel the k, 1 will cancel 1. So this will cause us to have what? To be left with, this will cause us to be left with the limit as h approaches 0, 0 of minus h over h k plus 1 k plus h plus 1. Alright, and this would be the limit as h approaches let me just write it on the other side because it's refusing to write here. So this would be the limit as h approaches 0 of minus h over, and then here, or did I write, let me see, yeah, the minus h will cancel already, so k plus 1, it's fine. Well, we should be left with minus 1 here over k plus 1 k plus h plus 1. You see, right? And this substituting will get us to have this, right? And this would be minus 1 over k plus 1 squared. I'm sure we agree with this. So if there's no question, we can proceed. But if you have any question, you can just stop me. Then we do the question. So now we come to the second part, right? And then we say this was what was D, right? We come to F or E. We come to E. So let's see what E says. E says x of f is equals to 3 over root. X of f is equals to 3 over root of f plus 2. And it means that we should first write the formula. You see, right? Then we have the limit as h approaches 0 of x of f plus h minus x of f all over h. And we know that we need x of f plus h, which should be 3 over the root of f plus h plus 2. Right, and this will be the limit as h approaches 0 of 3 over root of f plus h plus 2 minus 3 over root of f plus 2 all over h. And I've specified this. Remember, I specified this, and I said that what we need to do is multiply these two, right? Combine them, then we'll multiply them here. F plus 2, f plus h plus 2. We do the same for the denominator. Root of f plus h plus 2. Right? And then this would cause us to have, so it means that we're going to have this. We're going to have the limit as h approaches 0 of, we know that this would cancel this. So we'll be left with root of f plus 2 here, minus, and then we know that this would cancel this. So we'll be left with root of f plus h plus 2. You see, right? All over h times root of f plus 2 root of f plus h plus 2. So this would be the limit as h approaches 0. Remember, the step after here is to simplify, right? Plus 2 f plus h minus 2 all over h root of f plus 2 root of f plus h plus 2. So we see that 2 would be the one to cancel out. And then we'll be left with the limit as h approaches 0 of the root of f minus the root of f plus h all over h times the root of f plus 2 times the root of f plus h plus 2. Right? And then this would cause us to rationalize. This would cause us to rationalize. It would cause us to rationalize. We would come and say f plus root of f plus h root of f plus root of f plus h. And then here we would have the limit as h approaches 0. F by f would get f minus f plus h. So this by this, negative by positive, and this root by this root, as usual, how we compute the rationalization. So this would be all over. We have h root of f plus 2 root of f plus h plus 2 and root of f plus root of f plus h. Right, Then this would be the limit, and then we simplify that again. The numerator would have, so here would have f minus h all over h root of f plus 2. Then we would have root of f plus h plus h, then would have plus 2 root of f plus root of f plus h. Then this would be, f would cancel f. We agree, right? And then would have the limit as h approaches 0 of minus h all over h to root of f plus 2 to root of f plus h plus 2 and to root of f plus root of f plus h. Right, and here from here we see that root of h would, we see that h would cancel, right? H would cancel out. So would have the limit as h approaches 0 of minus 1 over root of f plus 2 root of f plus h plus 2 and also root of f plus root of f plus h. You see, right? Then this would be the limit. No, let's not plug, let's just plug h. Would have minus 1 all over root of f plus 2 root of f plus 0 plus 2 root of f plus root of f plus 0, and this would be minus 1 over, and this would be root of f plus 2 squared times root of f plus root of f, and this would be minus 1 over, and then this would be 2 root of f times root of f plus 2 all squared. So that would be the solution. That would be the solution to that problem. Any question? So if there's no question, we can proceed, right? So if you don't have any question, we can move it. So now we come to this. We're left with like 14 minutes. Then we come to this, right? So we did number 2. Yeah, I said that you should do number 2, B, C, D. So I think we can just complete this one, then we stop, right? Then let's do this one tomorrow, and then we'll also do these ones. Yeah, we'll do these ones tomorrow. I think we can end the session here so it doesn't become too long. So we can do this, and then today just please go try this. Mark yourself here, do corrections, then you try number 2, and then try number 2. Even those who didn't, I expect you to try number 2. then we will see this. We'll see how to do this tomorrow. So I'll make a corrections there. Those who are not finished or those who finished with this, you can let me know inbox that you finished with this number 2, so we can see what to do. But then those who haven't finished this, they can do it. So yeah, I think we can end the session here, guys. I'll stop.